Good morning, everybody. This is Howard from DataON. Welcome to our August webinar. This time, we're going to focus on the topic of optimizing storage spaces direct with SMB3 RDMA network. We are very excited to have a great speaker today joining us. We have Steve Akron from Microsoft, who will be talking about some of the new stuff in updating the S2D storage spaces direct on Windows 16. We have Multibex from Mellanox, who will share with you their knowledge about RDMA Fabric. We have Benjamin Clements from our partner Strategic Online Systems, who will share with you his deployment experience with one of the customer in Memphis called Youth Villages. Then I'll wrap up with some of the new stuff coming from DataON. And feel free to ask questions. We have a view on the Bright Talk that you could solicit, put your question in, and we'll try to answer them towards the end of the session. Just some agenda. I will start off, then I'll pass it to Steve. Then Multi will take over for the SMB3 RDMA Fabric. Ben, then I will wrap up with Q&As. Some housekeeping items. Make sure you're muted throughout the webinar, so we're very clear on the audios. There's a chat windows. We have social media tags, hashtags for all the presenters, so feel free to follow us and follow them so you can get the latest information via Twitter. So let's get started with Windows Server 2016 momentum. It was launched last year at Ignite. And ever since launch, at least from a perspective of DataON, it's been a tremendous technology and platform as we see continued adoption from customers with all the fields. And from some of the data we see from the industry, we see that software-defined data center as an infrastructure is really getting the attention of IT admins and decision makers, because it provides flexibility, it's a cost reduction platform, and also it's projected to continue to grow in a very accelerated rate. As a HCI, hyper-converged infrastructure, I think people understand the benefits of it, the benefit of ability to integrate compute, storage, and networking into a very simple deployment. And this is a market that across the board is looking to grow and really overtake a lot of traditional SAN storage. But as you look at the SDDC market, and you'll see through a series of our webinars that DataON has worked with Microsoft and our partners, we try to give you a perspective of different technology within the SDDC market. And we have talked about storage spaces direct at the hyper-converged infrastructure. We talk about storage replica. And as we move forward, you'll see how Azure and Azure Cloud continue to play a role with Microsoft, especially in how we move forward. Before I pass it to Steve, I also want to kind of share with you, Microsoft really have done a lot of work on certification and validation to make sure the platform that they work with, the partner they work with, have a complete turnkey solution to help our customer. And they launched the Windows Server Software Defined Program about, I would say, 3 weeks ago. And you could probably get it. Go and visit them at the Microsoft URL above here. It's actually microsoft.com/WSSD. And you'll see that there's a lot of information about certified platform, not just from DataON, from other vendors that really embrace the Microsoft solution. And there was an article that came out recently I thought was really interesting, in which it talks about, can Windows Server make hyper-converged infrastructure a boring commodity? What a powerful statement. What that really means is Microsoft really taking the architecture and trying to broaden the capability into the marketplace. And those infrastructure delivered by DataON as a partner are really pre-configured and stress tested. And it really spans across enterprise and large enterprise and hosting companies. And you really have a choice. You have a choice how you want to deliver to meet your workload. So having this capability with Windows 2016 really gives that flexibility and really make HCI a really great infrastructure to consider moving forward. So without further ado, I would like to introduce you to Stephen Akron from Microsoft. Steve.
Well, thank you, Howard. I appreciate the introduction. I'm Steve Akron, and I'm a program manager at Microsoft. I own the Storage Spaces Direct feature I have been working in the storage and high availability team for more than 10 years. And as Howard pointed out, we are working on making Hyper-Converged to be a very boring technology. We believe that high availability and providing very performant storage is something that should just be expected from a platform. And Microsoft has a lot of experience in providing distributed systems like failover clusters and network load balancing. And it's just a natural evolution to bring it to storage and bring the functionality you need to successfully run your enterprise and your business. So I kind of wanted to be the guy that gives some context for the other presenters of storage spaces direct and why networking and RDMA is so important. So if you look at a traditional storage array configuration, you usually have something like Hyper-V nodes consuming the storage. They connect over transport and go into a storage array. And the storage array, most storage arrays that you buy have some interfaces and configuration, but in general, they're kind of black boxes that you connect to and consume. And then if you kind of open up that black box and look at the components, what you see is what you have is a bunch of disks. You have a backplane they're connected to. You have storage software that manages the LUNs and the arrays, and then a controller that connects out into the systems. So if we take that architecture, we can bring it up into a set of servers. And in those set of servers, you have the disks that are either directly in the chassis or in JBODs. And we use the network transport as a mechanism to connect these individual servers into a single distributed system we call storage spaces direct. And by having individual servers, you achieve the idea of multiple backplanes, because each server ends up acting as a backplane, individual power supplies. They're an individual component for failure. And with the software and the networking connection, we can make it so that every node thinks it can see every disk, and we can make sure that any data that's given to the system is saved in either mirror, three-way mirror, or in parity, so that it's spread across the nodes. And so if any one or two nodes goes down, there's still data available, like you would expect in the storage services of the SAN. In the previous slide, it showed a configuration where the storage subsystem, or the storage nodes, S2D nodes, were a separate system, and then another set of servers, in this case running Hyper-V, would be consuming it through an SMB interface. We also provide Hyper-Converged, which brings one more level of simplicity, where you can take the same set of servers, you can have it, the disk local to the servers will give you the storage services, the highly available storage services through storage spaces direct, but also use those same nodes to host applications like Hyper-V and virtual machines. One thing that differentiates storage spaces direct from some of our competitors in the hyper-converged industry is that we are a pure software storage solution. In physical deployments, we rely on the hardware such as DataON servers, but we are not tied just to hypervisors either. For instance, you can run SQL Server on top of a storage space direct system and get extremely good performance with your SQL Server implementation. When you look at a system like a distributed system like storage spaces direct, it's helpful to kind of understand how the data gets distributed. So in this chart, we show a write workflow where you have REFS on the top, which is our preferred file system. When a write goes to the system, it goes down to the virtual disk layer, then the storage pool, and then from the storage pool, it will identify what the resiliency is in case, for instance, if it's three-way mirror, the write will actually get distributed to 3 different servers. so that there's a unique copy on 3 unique different servers. It first hits the caching devices, which means that the write, when it gets to these nodes, is put onto the cache device, which is usually a flash device, and the response back is very quick. So that gives us the performance advantage of being able to do these writes, get them quickly back to the system. One thing you'll note, though, is that all the writes go to 3 different systems, and then they have to respond back up the stack through a single node. So having good networking between these nodes is incredibly important, because everything we do, all the writes, some of the reads, transits between the nodes for it to be completed to whatever the workload is. So you need something in the system that's going to give you that really good write performance. You write down to the virtual disk, and then you see the 3 copies going down to the individual nodes. So when we're talking about storage spaces direct and the networking, as I noted, everything transits between the nodes. For instance, if a disk fails and there needs to be a rebuild, data will be transiting between the nodes. Any write coming down will have to go to multiple nodes and then respond and back up. So we do have some best practices. The biggest being when you're planning your networks, you want to make sure that you have at least as much network bandwidth and low latency networking, what we call east-west or between the nodes, as you do into the system. So if you're using converged networking, we're using the same set of NICs for both, setting up network quads that allows you to reserve SMB capacity. In our best practices, we suggest 40% reserve for SMB so that we can have enough bandwidth between the nodes to make sure that the storage I/O keeps up with the demands of other I/O coming into the system. We also have a support statement. We want you to use 10 gig E or better. Do we hard block that? No. You can go set up a test system with less, but for any system that's going to be that you expect performance out of and to be in production, to have a good experience, you need 10 gig E or better. We also highly recommend using RDMA, and there'll be more information later in this presentation about RDMA, but it gives you a significant increase in both the throughput, but also lower CPU. And in hyper-converged world, CPU is a commodity for virtual machines, and the less CPU you can use for infrastructure and networking, the more you have capabilities for hosting VMs on your system. CSV cache is a local read cache, and since it is a local read cache, any reads that are in that cache that come into the system can be responded to very quickly and reduces the east-west traffic. And with that, I'm going to hand off to Moti from Mellanox, and he will continue on the presentation.
Thank you, Stephen. Again, Moti Beck. I'm with Mellanox Technologies. I'm part of the market development team. It mostly focuses on the enterprise and working very closely with Microsoft to provide a complete solution. So just in brief about Mellanox itself, for the guys that don't know us, Mellanox actually provides only networking solutions or technologies. We have all the components that you need to connect servers to servers and servers to storage. We support all the networking standards, including TCPIP or Ethernet, InfiniBand and Rocky as well. And we support today all the speeds, the standard speeds in the industry that runs from 10 to 100, including the latest one, the 25 and 50. And our solutions include, from the component point of view, again, all the components that are needed, whether it's the cable, copper cable, optical cable, including silicon photonics, ICs, adapters, including also the software that makes it much more efficient and robust. Before going actually into the technology itself, I want to go over the effect of the exponential data growth that we have today in the industry. And we have it for a while, and I believe that it's going to continue for the next years as well. The issue is that with such an exponential growth, you cannot, or the industry cannot continue to use or to manipulate and process the data the same way that it was done in the past. Means to unload the CPU with all the different tasks that can be actually block the CPU from being efficient and effective. And the idea is here that the industry actually started already to offload as much as it can be done to the other components. Not offloading the CPU will result actually in a system that all the other expensive components in the system, including the network and the storage, are going to wait for the CPU to complete the job. And it's a very common scenarios today in the old deployments, I would say, that even if you put 100 gig per second network, the CPU is not capable to drive such a speed because it's busy with other tasks that are nothing to do with the processing the data that the CPU was designed to. So the industry started to look for ways to offload the CPU and to do as much as can be done on other components, and specifically I'm going to talk about the network itself. All in general, there are network functions, all the stateless function can be actually offloaded to the network subsystem in the modern deployment. And the idea is actually is not new. If we'll take actually from pretty not high-tech industry like the concrete industry, the industry is doing it for a while. Instead of doing the concrete in a central station, the method that they developed, including that basically helps in increasing the scalability, lowering the latency, and of course the overall improving the ROI, is to download to the machine or the trucks all the concrete and the other material, and this is being processed while in transit. In the same way, this is the same way that I believe that we can go and do with the networking as well. Status offload can be as, for example, like the IPsec that is very popular on the security industry or to secure data. This is a specific function that can be implemented as a bump on the wire. It's a stateless operation, so why not to offload it and to save the number of cores that runs between 4 to 6 that are associated when you are running it with the CPU. So if you are doing it, actually, you can actually eliminate or reduce the latency by almost 90%. And there are examples that I'll share with you later on that basically shows it. So the idea is to use as much as you can to offload the CPU from the CPU to the other sub-component, and I'm going to talk about specifically the networking itself, although there are many other offloads that today we support, like as I mentioned before, IPsec, but there are other storage, for example, Azure coding or T10diff, and many other, but I'm going to talk specifically about a technology that called RDMA. RDMA is current remote direct memory access and replaces actually the TCPIP. The TCPIP is a very robust protocol, but it is being used and will continue to be used for many years, but it's pretty heavy. To run a TCPIP on a CPU, it takes about good 4 cores. That keeps it busy because there are a lot of stages to implement the protocol itself. Many copies within the initiator on the left side to the target, and then it goes through the NICs and back. So you can see, and this actually slide illustrates very well the complexity of running the protocol. RDMA is basically offloads it, not 100%, but almost close to 100%. The CPU tells the I/O controller, which is the I/O controllers that are capable to do RDMA, to take a specific packet or a specific data from the initiator or the target, and tell me when you are done. The CPU is continue to do the rest of the operation to the computational, and the I/O controllers are negotiating between themselves, and in many cases even there is what we call a zero copies, that the NIC on the initiator writes directly, after negotiating, writes directly to the memory on the target side without even the involvement of the NIC on the target itself. With this one, you can see why it's so more efficient compared to the TCPIP, and this is why Stephen actually mentions that for the Hyper-Converged or the Storage Spaces Direct, Microsoft decided to choose the technology in the recent Windows servers. And again, the throughput is much higher. It's at least 2x higher throughput. The latency, and this is results of a low level without a real application load. This is just back-to-back connection between two servers, and we can show, and I'll share more later, that the throughput can be doubled. The latency is less than 1 microsecond. Actually, to be specific, it's 0.6 or 0.7 microsecond. And the CPU utilization is very, very low, because the only thing that the CPU needs to do is to tell the I/O controller move this data from this one to the other side, and it's pretty much done. And I decided to show the efficiency of the RDMA, what it can be done. And again, Microsoft was, I believe, the first or almost the first company to appreciate or to recognize the efficiency the RDMA technology can enable. And this is, I took the graphs or the slides that Stephen presented before, and I put in on one slide to show why the efficiency is much higher and better compared to the traditional approach that was on the left side. On the left side, basically, this is the traditional approach. You can see that, first of all, it's pretty complicated. In addition to that, you need two types of network. One of them usually was Ethernet for the compute, and then you have the other storage type of network, whether it's a SAS or a fiber channel. And Microsoft came with a disruptive technology or disruptive approach and said, okay, guys, the new data requirement requires new approach from the data. It cannot be that the CPU will be so busy and will wait for so much to get the data from the storage, and came with those two approaches. One of them was the converged, that has a dedicated servers for storage and a dedicated servers for the compute. And on the Hyper-Converged, there are only one type of servers, and you can see why it's so much efficient. But to get the same performance like the traditional, it requires a high-performance network like the RDMA can enable today. And immediately after that, I believe the first introduction was at Windows Server 2012, which was about 4 or 5 years ago. And with the introduction, Microsoft published actually a benchmark that shows why the efficiency is so much better. On the left side, there is about 50% higher efficiency compared to the traditional approach. Traditional approach versus the fiber channel, and also the traditional iSCSI that does not support RDMA. And the main reason for doing it is first to use off-the-shelf servers instead of, or off-the-shelf components, commodity hardware. Instead of using the old, I wouldn't say the old, but the very expensive fiber channel and the SAS, and you add different vendors and so on, and you need to match. Here you can use Ethernet. There are many vendors that support the Ethernet with RDMA today. And the first approach was the converged systems that has the compute and dedicated for the compute and dedicated for the storage. And this one actually gave about 50% higher efficiency. And later on in 2016, Microsoft actually added the Hyper-Converged that uses the same server for both and came with even higher efficiency. And today, as Stephen said before, it's very highly recommended, and probably I would say that it's going to be a mistake to use solutions today that are not supporting RDMA on the network itself. So you can see why the RDMA enables higher performance, and it's not cost you more. It's the NICs are the same cost as any traditional NIC, whether it can support only TCPIP. It's the RDMA capable NIC have the same. You don't need anything special on the switch. It's the same switch. Maybe I'll describe if I'll have time later, but it's the same switch. So the deployment cost itself is about the same, but the overall ROI is much, much better. And those are the results, and this one is a blog that, based on a blog that was published recently by the Microsoft team. And just to give you the more deep dive why the RDMA is so much better, this is a POC that was published a couple of years ago by Microsoft, that basically compared the ROCE, which is RDMA over converged Ethernet, to the TCPIP. There is something wrong on the slide, on the graph. So on the left side, it's without RDMA, it's over TCPIP, and the blue one is ROCE. And when they connected back-to-back on the right side, you can see when they connected back-to-back, just on the bare metal, connected back-to-back servers, when they ran over TCPIP and the link was 100 gig per second using NVMe storage, they got only 54 gigabit per second, while on the ROCE it was more than 90 gigabit per second, about 2x as I mentioned before. So the question is what is going on here? And when they analyzed actually the CPU or the core utilization of the solution, they saw, and I did it in a nicer way, although there is a link to the presentation, they saw that all the cores that were assigned to run the TCP/IP when running the protocol were fully utilized. You couldn't use anything else. While on the ROCE itself, very little, all the cores were almost empty, which shows that it's not just can explain the bandwidth, it can explain the latency, and why the CPU it's much more efficient, because today the CPU costs about $2,000, the I/O controller, let's say 200. So why to run the communication task on such an expensive machine instead of running it on the lower? And in general, it comes with a much more balanced systems that between the storage and the network and the CPU itself as well. Again, show just the efficiency of the RDMA. And it's not, the ROCE is very well deployed in mass deployment. One of the most public and well-known is actually at Microsoft Azure. I mentioned before that Microsoft was among the first to recognize and appreciate the value of ROCE. They actually started to deploy it a while back, still using at the time it was 40 gig per second. Today, again, it can run over 100 as well. And this is just a testimony about the robustness and the risk-free, I wouldn't say risk-free, but the very low risk when deploying ROCE in any small or large deployment, whether it's in a converged or hyper-converged system. And for many, since I would say for the last several years, we have been working not just with Microsoft, but also with DataON as a partner, and I'm not going to, Howard is going to talk about it more in details. but the solutions that DataON has include all of our end-to-end. That includes our Spectrum switch that can support up to 100, but 25, all the speeds, the NICs and the cables, pretty much robust, proven, compatible, and with the deployment that Agile has, and I would say that one of the best, if not the best, networking technology when you deploy a Windows Server in your company. So with this one, pretty much this concludes my presentation, and I'll move it to Benjamin that will give you, I believe, a perspective from the end user point of view. Benjamin.
Thank you very much, Modi. Glad to see everybody attending today. And Stephen, that's some great information that you gave us, and thank you, Howard, for bringing this all together. I'm Benjamin Clements with Strategic Online Systems Incorporated in Memphis, Tennessee area. And so what I was going to share a little bit about my experience is starting off of who we are. We, we're a technology company doing outsourcing, so we do CIO consulting, in other words, business side planning. We do technical side planning, project deployment, and then we do support and management of, our projects. So what we're going to talk about today is one of my customers. It kind of falls under the system architecture or the technical side planning. This customer is a large not-for-profit, great company, great organization. Youth Villages. And Youth Villages has been around for a long time. More than 30 years, they've been helping children and their families. They've been helping really problem children that have nowhere else to go, and their goal is to rehabilitate the child and their family and bring them back together. Great, great mission. They have 72 locations across the nation, and in terms of they have residential care as well. So they're doing a lot of great work. But in order to do all that great work, they've got 2,800 employees, lots of counselors. They're all taking data, of course, needing to track, the health, the everything of the child and of the family, and having to share that information. And they're having to produce reports, and then at the end to see the efficacy, the efficiency or the effectiveness of the treatment plans, how they're doing. So they need to keep track of all this data. And so they're heavily dependent on a huge electronic medical records platform. So, but as a nonprofit, of course, like a lot of us, they have, we need to make sure that we're keeping the budget in mind. And so, we had an iSCSI solution there that, is a decent-sized iSCSI solution with 72 spindles across 6 nodes, but we were really bumping up into the max capacity of that. And so as we're looking forward to, how are we going to move forward with able to take care of more kids, to allow them to reuse this data in multiple ways, to try to get to the point that we're doing predictive analytics, not just looking and see what's happened in the past. So I saw that we were bumping up a limit, and our main limit was our storage. So I had several goals for enterprise storage, and this isn't going to be anything new to any of you. We all hear about flash, and we want to take advantage of flash because of the low latency. We also want to take advantage of NVMe, and if any of you haven't tried the NVMe drives, basically think about an SSD flash drive where you take away the latency that even the backplane causes. So you're no longer limited by the latency that SAS can introduce. Well, to take advantage of those NVMe drives, of course, we want to take advantage of RDMA, as Modi was talking about, because RDMA then removes a lot of latency as well. And of course, if I'm talking about enterprise storage, and I'm saying these things out loud, and we're all thinking about them because we think about what is enterprise storage as opposed to storage just for a single server. So enterprise storage, because it's the backbone of everything you're storing, it has to be a tested storage solution. We're not just going to come out and put a Linux little solution together or try to reuse a blob storage and all of a sudden use it for a great SQL performance. And so it has to be a tested storage solution that has a history, okay, has a history of being reliable, robust, etc. It's got to have management software. That's what I was looking at. Have to have management software so I can see where I am. I can see what volumes are giving me what IOPS, what latency. I need to have alerts. I need to see what drives are going bad, etc. And of course, trusted vendor. And what I put as that is I'm looking for a trusted vendor that I'm hoping in 3 years is not going to be bought out. I've already been through something like that, and it was okay. But when that vendor is then bought out by somebody else, then you're always getting this thing of, oh, this solution is fine, but we have another internal solution that's even better, and of course costs twice as much. So then we finally get to the budget, and of course that's the pink elephant in the room or huge elephant in the room, whatever you want to call it. Of course, I'm looking to spend, trying to be very wise with the money, especially for a nonprofit, because you're talking about, you've got some donors who are giving of themselves and giving of their money. We need to show them, hey, we're using your money wisely when we're spending this, but we're trying to find a way that we're not having to also sacrifice performance. So, of course, and I think you can tell in my voice, when Windows 2016 comes out and Steve starts announcing, hey, storage spaces direct, we're taking storage spaces, but we're making it the SAN replacement. I was excited because I don't get excited about technology. I get excited by solutions. And storage spaces direct was what I was looking for because I had already deployed a couple of storage spaces solutions. And it was a great solution. It was starting towards that enterprise storage replacement. But, storage spaces direct, if it could actually deliver what it was talking about, I was very excited. So, of course, for my customer, Youth Villages, of course, I started to do my due diligence. So I compared storage spaces direct with the traditional SAN. And in this case, when I'm talking about storage spaces direct, I'm talking about one of the models that Stephen and Modi already showed, which is the converged model. And the whole reason that we didn't go hyper-converged is because we have a lot of really big Hyper-V servers, that are running 1 terabyte of RAM, that have 32 physical cores, that have 64 virtual threads, that we need to run these huge SQL databases in a large NUMA node that each have 512 gigs of RAM. And so we already had this big investment in this infrastructure of the compute and the processing resources. So what we were looking for is, at this time, is just simply traditional SAN versus a converged storage spaces direct. And so I started to kind of break it down. And of course, the number one thing up here, look at budget. It has the potential to be 50% of the cost of traditional SAN. And I'm not saying just potential. I was looking at it. I was pricing it. And we're talking 50%, depending on who you're talking about. And remember, I'm talking all flash. I'm talking about some NVMEs. But we're talking about literally potentially 50% of the cost of a traditional SAN. But even beyond that, because I'm always forward thinking, I'm not just concerned about the dollars I spend today or my customer spends today. I'm thinking about where we're going to be in 3 years. And something that always concerns me when you're talking about big storage is specific things like how the hardware and software are locked in together. I come from an old school where, we had, I hate to say the name Novell back in the day, but, when you'd have a server that was up and all of a sudden you had to replace it with a specific card, a specific RAID card, or you knew your server wasn't going to come back up, that keeps you awake at night. And so when I was seeing traditional SANs, a lot of them are locking in your locking in your hardware and your software together with a specific RAID card, with a specific backplane, so that when something goes down, a year from now, 3 years from now, you have to put in the exact same RAID card, or you risk losing that node, or you risk losing that volume, that RAID 5 or RAID 1 or RAID 10 volume. And that always kept me up at night. And here Microsoft comes out and says, hey, we're introducing a software-defined storage that you don't have to use one HBA. Yes, we put out a set of guidelines that you need to go by this guideline, but in 3 years, you will be able to find that an HBA card that will work. You will be able to find a backplane that you can put these drives in, and you can make it work. We're not locked in to one software and one hardware. We are dependent on a Microsoft server software that is built into every 2016 data center. Get your mind around that, because you're talking about your support base is absolutely huge of a software-defined storage, as opposed to a black box that you don't know what version of Linux they used, and you don't know what modifications they did, and there's a much smaller support base. And finally, well, let me go back to that. What I was also getting is the whole concept of, getting a traditional SAN, getting bought out by somebody else, and they had competing products, and so therefore, here comes the upsell when I want to do something different. When it's coming to the end of life, and I'm being trying to be upsold on a different product, the whole rip and replace upgrades typical. You might see that with traditional SAN. I sure heard about it a lot. And finally, layers of abstraction. I always like to see where my data is. And what I was seeing with traditional SAN is we were getting further and further away from where your data is. When a traditional storage vendor would say, oh yeah, we're now making it so it can run on your own hardware, we'll just make these VHDXs, these Hyper-V. But they're introducing one more layer of abstraction. I can't see exactly where my data is. It's in a VHDX, which is stored on something else, which is stored then on a RAID 5 or RAID 10 or something, as opposed to Storage Space Direct, where I'm looking at an SMB share, and I can see that's where my data is. I can do a shared nothing live migration to some other type of storage in a disaster, because we always need to be thinking, how are we going to get back our data? So, guys, for me, I mean, you owe it to yourself to, at least for the budget, to see what this thing can cost compared to traditional SANs. You owe it to yourself just for due diligence. So for me, I said, okay, I'm going to Storage Space Direct. I see that's the future. I see Microsoft is supporting it. I see they have a roadmap for the future. I see that they are battle testing this product with internal processes, with Azure processes. So now that I'm going Storage Space Direct, why did I choose DataON? Well, I did do my due diligence, of course, and checked out all the big hardware manufacturers. We have relationships with all of them. And the one thing I kept coming back to is that DataON was single-focused, saying this Microsoft solution is a legitimate solution, and it is very, very viable, and it can be a SAN replacement. Whereas I kept getting from other storage that, yeah, Microsoft Storage Space Direct is a good product, but you really want our other product that is X, and it's still made by us, and so you can still work with us. So I kept feeling led to another internally competing solution. DataON is focused to make Microsoft storage spaces the best it can and to present it as a SAN replacement. And so in my due diligence, following up with DataON, I kept getting all these documents, notes, everything that were saying DataON is the expert in storage spaces, and they are committing the resources to making Storage Spaces Direct work. And they can bring together the resources like Modi, like Steve, to bring together their knowledge and their resources to make this work, which leads me to finally why DataON is because they are committed to a SAN replacement. They don't want to just be an enterprise storage. They want to be the SAN replacement. They're not selling you hardware. They're designing a storage solution. And also Must, Howard's going to go into this briefly. Must is their management and monitoring tool. It's the tool that we all expect from a SAN to be able to tell us what our volumes are doing, what our nodes are doing, what our latency is, where our problems are, what drives we need to replace, etc. That's an important part, and Must sets them apart. Must sets DataON apart, and it's a brand new product. They've been using Must since the Storage Spaces days, and they just need to make some tweaks, major improvements, but to support Storage Spaces Direct. And then finally, the support they give is not for the hardware, and it ends there. It's for the whole solution. So what they want to do is they want this thing to be a SAN replacement. So are there challenges of Storage Spaces Direct? Yeah. I mean, just because, as the guys alluded to earlier, the challenges are due to the increased capabilities, the increased performance, increased flexibility, increased scalability. And what do I mean by that? Well, if we're using RDMA, we use RDMA because we want to get those low latencies of the NVMEs, and we want to use those and use that effectively. What good is the NVMe if then we have all this latency coming from just using normal TCPIP stack? And so that is a performance opportunity, but it also presents a challenge because we got to really think about our Ethernet fabric that's going to be connecting these nodes. The flexibility also because now we're not limited to SAS drives. We can now include an NVMe, which has no backplane really. So we've got to use our networking, our RDMA, to connect these NVMe drives together. And also the SATA, because you can use now SATA SSD drives that can be slightly cheaper than the SAS SSD drives. And then we have Storage Spaces Direct, linking them all together. And so the last one, you got to keep this in mind. Networking, networking, networking. Remember now, and I'm pointing this out, it might be obvious, but we have three different networks that we have to think about. We have to think about RDMA for east-west traffic. This is the traffic between the nodes of a Storage Spaces Direct. Okay, so all four nodes, like in our case, we have four nodes, they're talking to each other. And, you know, if you're, our solution has 3 copies for each piece of data. So as Steve said, we could have 1 or 2 servers go down, any one of the 2. It doesn't have to be only the odd servers go down or only the even servers go down. It can be any 2 servers go down, and we're not losing data. So RDMA for east-west traffic is crucial. RDMA for connectivity to your client, and we're talking about if a converged infrastructure, if you are doing a SAN replacement with Storage Spaces Direct. And then remember, this is Storage Spaces Direct is leveraging proven Microsoft clustering technology. And the reason I point this out, if it's using Microsoft clustering technology, it means it also needs to be registered or connecting to your Microsoft Active Directory infrastructure. So before, we had our SAN totally separated from our internal network. Well, we needed to account for that, and we needed to make sure that that was now connecting to our Active Directory. So some prerequisites for steps for us. We were actually overrunning our switch. We had what we thought was a great switch. We started overrunning it because 40 gigs, you're generating a lot of traffic. So we implemented 40 gig Mellanox NICs. We implemented 40 gig Mellanox switches. And then we worked with DataON and Microsoft and Mellanox for the configuration of those switches with certain buffers, data center bridging, that's the DCB, and priority flow control. Guys, we're back to flow control because we're going so fast we can drop packets. So priority flow control is one of those things required for, as Modi said, RDMA over converged Ethernet, ROCE. And so on our networking, we needed to on the two things. We need to create a new path from our storage to our Active Directory. And we need to kind of keep that thing separate and know which path we're going, because that path doesn't have to be blazing fast, but it needs to be consistent. We also need to simplify our networking, because again, we want to focus all of our attention so that our client servers, our Hyper-V servers, we're hitting that storage spaces direct in as fast as way possible, lowest latency possible, and that our nodes were connecting to each other, lowest latency. And then finally, configuration. When I say configured clients, I'm talking about our Hyper-V servers, configuring them with the Microsoft Data Center Bridging, with Priority Flow Control, with QoS. Now, so end results. So what did this make a difference for us? Well, what you're seeing is a graph here. It's a utility that we use. It's a product made by SolarWinds called Database Performance Analyzer. And it does certain things by, this is one of the graphs that says, okay, we're looking at a big database that's a 2 terabyte database with huge log files and 8 temp DB files and 512 gigs of RAM, etc. Where are our biggest weights? And we kept seeing our biggest weights were storage. And you'll see it shows days of storage because it's running all these parallel processes. You know, we were running it with 32 virtual CPUs at the same time. So we were having all these weights. This is on a 512 gig RAM SQL box. And we implemented, you can see where we scaled in, because we always scale in just to make sure to eliminate to reduce our risk. So we scaled in, and you can follow the arrow down to 59 times reduction in weight on storage. I'm not saying it's 59% better. I'm saying 59 times better reduction in weight on the storage. Yeah, going from iSCSI with 15K SAS is not as fast as SSD. But we were not talking about a cheap solution with no spindles. We were talking about 72 spinning drives, all going at 15K, and we still see a 59 times reduction in weight on storage. To me, that is something to be excited about. And it was all, you know, we see this performance, and it's a SAN solution. I am thrilled with the product that Microsoft's come out with, the tools that Mellanox has given, and for DataON bringing all of it together to help us as we help our customers. And Howard, let me pass it on to you because I'm about to get excited.
Thank you, Benjamin. That was incredibly awesome, and thank you for sharing your story. I think we got 5 minutes, and I won't spend that much time on it. I think the key message I want to get across are really in this 2 slides. First slide is, many of the customer on the webinar, they know that as a company, DataON is absolutely focused on delivering the solution for Microsoft, and we have a lot of experience doing storage spaces. And even with the launch of 2016, we now have over 100 petabytes of data deployed on Windows 16 platform. So we really have a lot of experience behind us helping our customer. And the momentum that we see in the Storage Spaces Direct and Storage Spaces Windows 16 is incredible. Not only existing customer evaluating additional solution with S2D, but we have in the last 6 months on over 30 deployments just on Storage Spaces Direct Hyper-Converged infrastructure. So you can see the momentum is generating the excitement that everybody has, and feel free, and if you have any questions, definitely reach back out to us. We're happy to help you across the board. With that, I'm going to open up to some quick questions. We've got 5 minutes, and we got some questions from the audience I want to get to. The first question was Stephen. The question for the audience is, can you give us some kind of sneak preview of what's going to come up in the 2016 release on Ignite? Something you could share?
Well, in our new spring release, we're calling the 1709 release, we're going to have some significant improvements in things like the performance for parity spaces. And you'll see that the parity performance is going to be much closer to mirror than it was before. And then we have some new exciting hardware solutions, including some from DataON that will be highlighted and shown at Ignite.
Thank you. And Moti, from your side, if the customer want to find more information how Mellanox supports S2D, do they have a good place and documentation they can go to in the future?
Yeah, actually you have on our website quite a lot of material, including reference design and architecture. And you know, always you can email me if you are missing something, moti@mellanox.com, but there is enough. One thing that I want to mention about what Benjamin said, you can run today to get the maximum performance of ROCI or RDMA. The best is to use the priority flow control. But if you don't want to use the priority flow control, recently we announced a solution that you can run ROCI over lossy fabric using ECN. The documentation is also available on our website, but if you do just a simple search, you'll find it as well.
Good. We're going to wrap up with Benjamin. Benjamin, any last words for all the audience? 52 of them online that really love your story. Anything last words before we wrap up?
Yeah, I would just say, it's worth your time for due diligence sake, to check it out for yourself, because you will hear storage vendors go, oh, you're not really trying to get a real sand replacement doing that, are you? And, there's that whole just being skeptical. And I heard that, and it's just, I wouldn't have pushed on so hard except for what I had been studying, 2 years prior to Storage Spaces Direct coming out. So you owe it to yourself and your organization to at least look into it. If not for the budget, then for future-facing support. Support down the road. But yeah, budget. Give Howard a call. Seriously. Or give
Thank
me a call.
Yes, you're my partner. We'll definitely give you a call. So we got more questions, but we'll respond to you via email, guys, if we don't get to it. Thank you so much for your time. Thank you, Stephen. Thank you, Benjamin. Thank you, Moti, for joining. And we can't wait until see you guys all at Ignite. We will be there. DataON will be there. We'll have a big booth. Benjamin will be there. So we look forward to meeting all of you at Ignite and ask us all the questions. Thank you very much, and see you next time. How do I close this?